Hello guys, welcome back to my channel. I'm back again with another new stuff, and now I'm going to introduce you to one of the best timetables which I also have followed for my September attempt last year in 2020 for JEE Mains. And you can see that when I was preparing for nearly for both JEE Mains and Advanced, I followed this type of timetable, almost the same, but not but there will be some changes which is more better for you. That if I would have done this, I would have got much more greater score in JEE Mains. But now, yeah, I'm showing an ideal timetable which anyone can follow for 3 weeks in 21 days, and a fourth week for mock test, by which you can get much more increase in your marks in your JEE Mains examination. And math percentile matters more than physics and chemistry, because when the percentiles tie up, math percentiles make up the difference. So let's start with the video. As you see, the first one being the week 1, which is more of foundational chapters like trigonometry, straight lines and circles, relations and functions, quadratic equations. These are usually taught at the first. As you see, functions make up a base for most of the calculus. Quadratic equations do appear in most of the algebraic, and it appears as a part of many chapters. And straight lines make up the base of coordinate geometry, and trigonometry, of course, is the base for most of the mathematics as concerned with JEE. As you see here, we are dealing with nearly 6 chapters, and the chapters marked in black are those core chapters which come in both JEE Mains and Advanced. The blue ones are those which are the chapters that obviously come in both JEE and Advanced, but they are universally used chapters. That means these pop up in collaboration with other chapters also, like quadratic equations being framed with binomial theorem, functions with continuity, differentiability, trigonometry obviously in many chapters including complex numbers, sequence series, most of the coordinate in parametric forms, and in functions, calculus, integrations, etc. Trigonometry comes everywhere, and straight lines come most of the coordinates, and 3D also. Straight lines is it's an introduction to 2D, right? It can be extended to 3D also. So this week 1 is very beneficial as it makes a profound grip on your foundations. Coming to week 2, as you see here, we're going to enter core calculus. We start from limits, continuity, derivatives. Then we'll come to applications of derivatives, integration, indefinite and indefinite integration, area under curves. Then we move to differential equations. Then you come to basics of conic sections. I'm not including whole of conic sections here, because most of them consider that it's very difficult to complete this at this point of time, because we don't have much time for preparation, and deep parts of conic section require so much of arithmetic and so much of patience to understand them, and remembering is also not an easy task. Coming to some, we'll be entering algebra again at binomial theorem, matrices and determinants. Now in these, of course, I have shown the black bolded chapters are important here, which have either they are very high scoring chapters with less questions, or with higher number of questions but being somewhat difficult. I have marked in black bold. Coming to the third week, where we see vectors in 3D. I kept vectors in 3D because usually also vectors in 3D come at last in our CBSE syllabus, and also probability. Also that vectors in 3D can be done after we do the coordinate geometry, because vectors in 3D become an extension of 2D, because 3D is much better understood after understanding through 2D. So after that we have seen probability. Probabilities also come usually in the last parts of CBSE syllabus, and of course statistics, set theory, mathematical reasoning, heights and distances. These all are JEE Mains specific topics. You have to master them at the last, so that we can remember most of them while we do our mock test. And if we remember them the most, and questions obviously will come from them, we can do them, or we can definitely solve them easily during our JEE Mains examination. I have included another slot for any other topic that might get excluded, like inverse trigonometry, or maybe permutations and combinations. Which permutation combination I didn't include because many of you would be considering it as a difficult topic, but if you want, you can consider, if it is your good grip chapter, then you can definitely include it here. Or yeah, that's it. And week 4 again, if you actually, I recommend, don't do week 4 will be that week where it will be your exams week. Like for week 4 only 2-3 days will be left for your exam. For some it will be 5 days depending on your shift, and in those days I prefer you do one mock test every day except a day before the examination, because I don't want you to get exhausted by doing a mock test. So leave taking mock test at least 24 hours before the timing of the examination. That's my recommendation to you all. And also, if you are that desperate to do any topic, then I prefer you just revise trigonometry formulae. That's it. Coming to the next ones being, I want to show you the important topics, subtopics from each chapters. Let's start from quadratic equations. As you see, quadratic equations, mostly questions come from sum of roots, product of roots, nature of roots, common roots. That's it. And location of roots, sometimes they pop up. And coming to complex numbers, the basic properties of iota, polar form, Euler form, De Moivre's theorem. Then you see properties of conjugate, modulus, argument. Then you see locus, geometry related to straight lines and circles only. I don't want to move beyond that because they won't be asked that much. Ellipse and hyperbola in complex numbers are not that asked in JEE Mains. Yes, they can be asked in JEE Advanced, but we are not concerned with that now. Coming to relations and functions, as you see, equivalence relations. The topics which are kept in bold are the most important in these. As you see, functions 1, 1, on 2, they will be asked. Domain and range is very important for testing 1, 1 and on 2 also. Coming to composition of functions, these are very frequently asked in the examination if you go through the PYQs. Coming to inverse of function is obviously asked. And functional equations, they too tend to ask the standard functional equations, and even odd functions, periodicity, they do come up in combination with other chapters. Cartesian product, I don't think they'll ask much. You can leave it if you want to. That's it. And trig, obviously, all formulae. And in trigonometric equations, I want you to remember the general solutions, sine, cosine, tangent, and some standard solving techniques. There will be some standard solving techniques and questions related to that, like sin x plus sin 2x plus sin 3x plus sin 4x equals to 0, like those questions. You can try to do them. Coming to the next chapter, that is sequences in series. You see AMGM inequality, you see infinite GP, you see telescoping series, which can be mixed with inverse trigonometry or any other chapter, or binomial also, but series related to binomial, and series related to sigma n square, sigma n cube. There will be some series and some miscellaneous series that you have to practice something. And basic AP, GP, HP is very important. The arithmetic means, nth terms, and some of terms in AP. Those all are very basic. They are already taught in the AP is already taught in 10th class, so you can go on with that. Coming to straight lines, as you see, it's the foundation of coordinate geometry. So keep up the grip in that, so that you can boost your score in coordinate geometry. As we start with knowing all the forms of straight lines, then we go through perpendicular distance, angle between straight lines, section formula, collinearity, area of triangles. Then we move up to family of straight lines. Then we have special points in triangles like orthocenter, the circumcenter, centroid is important again in that. So straight lines as a foundation is very important. So do try going through all the concepts, just browse through all the concepts in straight lines, barring the special points in triangles. I don't think from orthocenter and circumcenter they'll be asking. Except that, I don't think straight lines should be left out. Straight lines is something which is already scoring in itself, but it is also a foundation to many other chapters in coordinate geometry, especially in the form of tangents and normals and chords. Coming to circles again, we have to know all the forms of equations of a circle, and the equations of tangents and normals for circles is very important. In general, for any conic sections, you have to know all the equations of tangents and normals related to it. Common tangent between two circles is very important, family of circles, and common tangent in general, common tangent between a circle and a parabola, circle and an ellipse, a parabola and an ellipse. Like those questions are very frequent in JEE Mains. You should definitely try those questions. Common tangent between any two conic sections. Even circle is a conic, parabola is a conic. Of course, ellipse and hyperbola are already conics. So try solving questions related to common tangents in between conics. Coming to next, we have relation between circles, that is whether two circles intersect, they overlap over each other, or whether they are disjoint circles. You have to get to know by some conditions between that are related to their radius and the distance between the centers. And lastly, the direct circle. If you like, they won't be direct questions related to it. You can if you get to know about the direct circle, it can make your question easier. Like, direct circle is a locus of points which of a circle whose tangents are perpendicular to each other. Yeah, that's the definition of a direct circle. If you can go through it. And coming to calculus, you're getting into calculus now. Starting with limits, obviously the L'Hospital's rule is the most important. The L'Hospital's rule is obviously the important, and if you don't want to just rely on that, try remembering the trigonometric, exponential and logarithmic limits, and also do try to remember the Taylor series for sin x, cos x and e to the power x. For tan x and all, I don't think it's easy to remember tan x and others. A log of 1 plus x you can remember if you want. Coming to continuity and differentiability, in here we can see continuity at a point, continuity at an interval, or if you want, questions can come from graphical approach questions, like find the number of the points of discontinuity or points of non-derivability, like for functions like maximum of f of x, g of x, for functions like modulus, functions like the greatest integer function, fractional part functions. You should know graphing properly for this to do. Coming to application of derivatives, this is the last chapter in our differential calculus. In this, the important topics will be tangents and normals, maxima, minima, mean value theorems. Then you have some application based errors, rate of change, which are generally taught in physics also. So you can try on that. And increasing decreasing functions, first derivative test, second derivative test, and some graphs also. In graphing is important for this. Let me move to integration now. Starting with indefinite integration, although it doesn't fetch much questions, mostly one question will come, but it is a prerequisite to other future chapters like definite integration, area under curves, differential equations. It's very important. So making a base is important, like how straight lines is important to coordinate. Indefinite integration is important to integral calculus. Starting with indefinite integration now, let's see. Here we have integration by substitution, integration by parts, and some standard integrals are important. There will be some standard integrals for which results are already proved and kept in handy, so you have to go through those standard results. In integration by parts, the dilate rule, you have to follow that. Other than that, indefinite integration, normal questions will be coming, not much difficult questions. And if you are very good in integration, you can definitely get good marks in integral calculus, because most of them are found by. And also in indefinite integration, as we start, we go through the king's or queen's rule, that is integration of f of x from a to b is equals to integration of f of a plus b minus x from a to b. That very famous king's or queen's rule, whatever you call, you can try that. That's very important. I think that can solve mostly 50% of your questions that come from definite integration. And also limit of a sum as an integral, and properties of integrals like the even odd property, the periodicity property, and other properties of integrals which are like basic and foundation for solving definite integration. Coming to Newton-Leibniz theorem, these questions are asked in 2020 when I was taking the examination, but I didn't go through the previous year's paper much. But in these few recent years, when NTA came into existence for JEE Mains, Newton-Leibniz theorem have been started to increase in asking. So try the Newton-Leibniz theorem also. It's very easy. I should say it's a very easy concept to understand. Let's move to area, that is area between curves, that is in general for area they'll ask area between conic sections or between conic section and a straight line, and usually that straight line is also a tangent or a normal. So going through circle and parabola, two parabolas, parabola and its tangent, ellipse and a parabola, ellipse and its tangent, like that. And rarely they'll ask from trigonometric functions also. So just go through, it's just simple integration, so you can just try it. It's a very simple one. Just you have to visualize the curve properly. Coming to differential equations, we have variable separable method, we have linear differential equations by integrating factor method, then you have word problems related to it, then you have remember variable separable method. That's very important because these form the base to solve other methods like homogeneous equations, linear differential equations. And for this, integration is also important. Integration is a prerequisite for differential equations obviously, and the formation of differential equations as such, I don't think much questions will come because they don't think, rarely, not rarely, usually they don't ask, occasionally they ask some questions on that. And degree and order, I don't think much will come. Bernoulli is important again. Bernoulli is important, so do solve Bernoulli related questions, that is related to substitution in linear differential equations. Coming to basics of conic sections, then you have basic elements of conic sections like focus, axis, directrix, vertex, eccentricity of a parabola, ellipse and hyperbola. Then you have questions like common tangents between conic sections like parabola, ellipse and hyperbola. Then you have to involve between circles, all the four, whatever, they can revolve around any two of the four conic sections. You have to remember standard tangent equations of all the conic sections including circle. Like for parabola example, I am saying that y is equals to mx plus a by m. Then the parametric forms for the three are important. For parabola especially it's very important, and circles also you can try to remember, which is just a cos theta and a sin theta. And focal chord of parabola is again something they'll try to point out, or indirectly, not directly. Indirectly they'll ask questions on focal chord. If you know the properties of it, it can help you save time during the examination. Coming to binomial theorem, you have, in general they'll ask tricky questions but on simple concepts, I should say, from general term, middle term, independent term. The formulas for these are very simple and direct, but usually they'll not ask very simple questions on it. They'll try to involve different chapters, and an application for binomial, application for being reminder finding related questions, fractional and integral parts questions, and also properties of binomial coefficients. You can try to go through that. And multinomial theorem, they usually ask some questions related to that, not in majority, but they do try to include that. Coming to matrices and determinants, very important, almost three questions usually asked out of 30. So try to go in deep with it. Also I'm showing the important topics for these, like going through transpose, symmetry and symmetric matrices, adjoint, inverse, determinant of a matrix. Then the most important topic, I should say, in matrices and determinants will be the system of linear equations using Cramer's rules, and also homogeneous system. These form 50% of your importance, I should say. Almost one question will definitely be coming from the system of linear equations. So this is something very true, shown in every shift. Nearly every shift had one question from, in 2020 especially, every shift nearly had one question from system of linear equations, whether it being a homogeneous system or a non-homogeneous system. They usually ask relating to consistency and inconsistency, that is whether it's a unique solution or a no solution or infinitely many solutions. And in homogeneous system they'll ask about trivial solutions. I just have to take it's a very simple concept because Cramer's rules is very simple, and from a simple concept, if every time a question is coming, then you should not leave that. Coming to next, that is from vectors. Vectors again, usually product of vectors, that is cross and dot product will be asked. Angle between vectors, vector and scalar triple products are the important topics, very important topics in this. Their geometric interpretation, like scalar triple product is shown as the volume of the parallelepiped. Then also linear dependence of vectors, like collinearity between vectors, coplanarity of vectors. These are something not very frequently asked, but they'll definitely try indirectly asking through 3D also, because in 3D when we say 3 points are collinear, you can try to prove that using 3D, but vectors show a much simpler solution in that case. So vectors in 3D can be interchangeably used in each other's questions, so that's why it's important, and they are given a combined weightage of nearly 4 questions. And in coming to 3D at the same time, direction, cosines and ratios. Then you have equations of straight lines in 3D, equation of planes, the different forms of planes, and the normal to planes. Then you have angle between planes, angle between lines, angle between a line and a plane. Then you have perpendicular distance of a point from a line or plane. Here we come to it is analogous to 2D straight lines. Distance of a point from a line. The formulas are so analogous that you can relate to them. And you have skew lines and distance between skew lines. That's a difficult formula to remember, but do try to by heart, and you will get it, remember, and score good marks in 3D geometry. Coming to our last 3 set of chapters, that is from probability, statistics and set theory. Probability, usually 10th class level and little enhanced level questions will be asked from probability, and also conditional probability, something very important. And I have marked random variables. Whole of random variables is very important for as per the random variable syllabus, that is various distributions in random variables, which is prescribed by CBSE Maths textbook, because in some states they usually include Poisson distribution also, which is not included in JEE Mains, so don't go through that. Usually whatever is prescribed in the CBSE textbook, go through that, whether it's Bernoulli or other distributions. Random variables is very important probability. Most of the questions try to come from random variables only, rather than conventional probability questions. Coming to statistics, obviously everyone knows this. Variance and standard deviation make up most of the statistics questions, and do try to go to mean, median, mode if you have time. And set theory, De Morgan's laws and Venn diagrams are the most important, because set theories can be used in probability, they can be used in mathematical reasoning, they can be used in relations also, like relations and functions. So go through set theory, very important case, because they can be used in much set of they can be used in 3 chapters as I mentioned. So, and in itself also there can be 1 question that can be fetched from set theory usually. So with this I end up with this video, and please like and share and subscribe to my channel, and do check out my channel through this link. I'll definitely post this PDF in the description. Please go through it and stay tuned for my next video. Thank you very much. Bye.